All right, so today we are looking at day 2, which is, reviewing, going over some of the intricacies of the two-way table. Is there an association between chores and curfews? In other words, do students who do more chores also have a stricter curfew? Now, curfew is the time at which you must be home at the end of the night. So, especially for kids who have a license and the ability to travel, or maybe they live in a city so they can walk, or they can take a subway, or they can take a bus system, curfew is something that comes up a lot. What time do you need to be home at the end of the night? The data for 27 students in the two-way table below is fabricated, made up, to make a point. Assume that curfew is the independent variable. That means that you should calculate the total number of students having early curfew or late curfew when you create a relative frequency table. If I interpret that for you, independent curfew goes on the top. Then the columns of curfew will add up to 100%. So early curfew, there were a total of 18 students who had early curfew, and there were a total of 9 students who had a late curfew. So when I go to do relative frequency, if early curfew and late curfew is the independent variable because it's on the top, we would say what percentage of students had an early curfew that do chores? That's 9 out of 18, that's 50%. How many have an early curfew and do not do chores? That's the other 50%. How many have a late curfew and do chores? 0 out of 9 would be 0%. And how many have a late curfew and do not do chores? That would be all 100% of kids with a late curfew do not do chores. Is there an association between chores and curfew? Absolutely. If we look at the kids with late curfew, so students with a late curfew did not do chores. I started to write does, I think. Did not do chores. Versus an even split of students with an early curfew. So very clearly, there was a correlation here between students with a late curfew not doing chores. Does doing chores depend on whether you have an early or late curfew, or does having an early or late curfew depend on whether you do your chores or not? Doesn't matter. So let's explore those questions. This time, assume that chores is the independent variable. So now we put the chores on the top. Complete a new relative frequency table by finding the totals of not doing chores or doing chores, and we're going to see if we find the same association. So if you do chores, there were a total of 9. Does not do chores, there was a total of 18. So remember, we're always adding the columns unless told to do otherwise. And when the independent variable is on the top, those are your columns. So early curfew does chores. 9 students do chores out of 9. So that's 100%. Does chores. If I have kids that do chores with a late curfew, that is 0%. So nothing changed, right? By changing which thing was on the top for independent versus what was on the side for dependent, I still got that same split of kids who do their chores. Does not do chores, 9 out of 18 would be 50%. 9 out of 18 again would be 50%. Got the same data. Does changing the independent variable change your conclusion about the association? No, same association as above. However, you do need to make sure that you're doing it in columns. You can't just, change where you move things and then be like, heck, I'm going to do it across instead of up and down this time. You're always going to be looking at columns unless you are told to start with something different. Now consider this new group of 27 fabricated students. For these students, is there an association if curfew is the independent variable? So you'll notice we put curfew on the top. And we're going to say 6 and 12 makes 18. We're going to say 3 and 6 makes 9. Early curfew, 6 out of 18. That is 33.3 repeating percent. Early curfew, 12 do not do chores out of 18. That is 66.6 repeated percent. Late curfew, that is going to be 3 out of 9. That's 33.3 repeating percent. And 6 out of 9 would be 66.6 repeating percent. Now, this one had the independent variable on the top, and this had the independent variable on the top. So we did everything in columns, 6 out of 18, 12 out of 18, 3 out of 9, 6 out of 9. This one has put does chores on the top. So this one, we're going to have to look at this relative frequency table, and this time we're going to have to do it across. We're going to say the 6 and the 3 makes 9. We're going to say the 12 and the 6 makes 18. We're going to say 6 out of 9 is 66.6 repeating percent. We're going to say 12 out of 18 is, nope, am I doing that right? Does not do chores, late curfew. Does chores with a late curfew. Oh, sorry, that's the other 3 out of 9. That's the 33.3 repeating percent. See, I always get messed up when they tell me to do it in the other order. Does not do chores. So that's the 12 out of 18. So that's 66.6 repeating percent. And then does not do chores with a late curfew. That's the 6 out of 18. That's 33.3 repeating percent. So did anything change by changing where our variable was? No, we still got the same results, even though we changed the direction that we did the data in. Like I had said before, we were specifically asked in this one, does not do chores as the independent variable. Then we had to work the table across. What is interesting about relative frequency tables that have no association? All rows and columns have the same percentages. All right, so in this case, we could say kids with an early curfew are more likely to not do their chores. Kids with a late curfew are more likely to not do their chores. So in this one, we would be like, well, there's no association. The early curfew kids aren't doing their chores and the late curfew kids aren't doing their chores. So no, we get the same percentages all around. And it doesn't matter which one we consider the independent variable. All right, last but not least, on the back of here, you will notice that there is math notes where it has a sample two-way table. The relationships between two categorical variables can be displayed in a two-way table like the one below. In the example below, one variable is the gender of the student and the other variable is the class level of the student. So on this one, class is considered the independent variable because it's on the top. And so this would be like if we wanted to say, if the student is the junior, what is the probability that they are female? Or if the student is a senior, what is the probability that they are male? So junior is on top, and that would make it the independent variable, or senior is on top, that would make it the independent variable. When entries in the tables are frequencies or counts, this is a frequency table. So these are all counts. The entries in a joint two-way table are called joint frequencies. The sum of a row or column is the marginal frequency or marginal distribution. You will not be asked to memorize this vocabulary, just for the record. In the two-way tables above, the joint frequency of senior males is 49 students, senior and male. So 49 fits in both categories. That's why it's called joint frequency. It's the joint senior and male, and it's the frequency, so it's the count. And the marginal frequency of freshmen is 103, meaning just freshmen total. We're not doing freshmen and some other category. A relative frequency is a percent or proportion of some subgroup as opposed to count. The conditional relative frequency of being female, given that you are a junior. So junior is independent, okay? Another way to say this is, if you are a junior, what is the probability that you are a female? And you will notice that in the question they said, given that you are a junior. That's the same as starting the statement with, if you are a junior, what is the probability that you are female? They worded it, the conditional relative frequency of being a female, given that you are a junior. And the statement can be done either way. In both cases, we are assuming that the person is a junior. That means we are only looking at the column of data for juniors. And how many female juniors are there? 68 out of 108. So that's where they're getting the numbers from.